Okay, so our next section is going to be on some different properties of operations. And these properties are properties that you might have heard before. You're going to hear a lot of as the year goes on. So just a couple of things, a couple of vocab words before we look at our examples. A property in math and a counterexample. So pause your video, go ahead and get these words down, and then we'll talk about them. Okay, so a property is a statement that is true for any number. So a property in math, and the same thing works in science as well, it has to be true for every single number. It is always true, always the case. If it's not true for at least one number, that means that it is not a property. And the way that we can show if something is a property or not is to figure out, can we show any counterexamples? A counterexample is an example that proves a statement is false. So very important, if we can find one counterexample, if we can find just one counterexample for a statement, then it cannot be a property. Because if there's one number or one example that doesn't work, that means it doesn't work for every single number. Okay, so we're going to be working with some counterexamples at the very end and looking at those to see if a statement can be called a property. So the different property, there are 5 different properties that we're going to be looking at in this lesson. So the first 2 are up here on the board, the commutative property and the associative property. Pause the video and get these 2 properties down, and then we'll talk about them and get the examples as well. So the commutative property, it says that the order in which numbers are added or multiplied does not matter. So notice that we are talking about addition and multiplication here. So it doesn't, not for subtraction, not for division, just adding and multiplying is when this commutative property can work. So the order doesn't matter. We can switch up the order when we add, we can switch up the order when we multiply, we're still going to get the same thing. So if we use symbols, A and B can be any number, we can switch the order around. An example would be 2 plus 4 equals 6, as does 4 plus 2. Okay, an example for multiplying would be 2 times 4 equals 8, and 4 times 2 also equals 8. So the order does not matter there. All right, the associative property. Think about the word associate. To associate with somebody means to be maybe grouped with them or to be together. Parentheses in math are how we associate 2 numbers together. Because think about, we do what's inside the parentheses first. So if it's in parentheses, it's grouped or associated together. So that's what the associative property says. It does not matter when we add or multiply which numbers are grouped together, which numbers are associated together inside the parentheses. So an example of that would be if we had parentheses 2 plus 3 plus 4. We would do 2 plus 3 first, which is 5, and then 5 plus 4 gets us 9. And if we then switched up the parentheses and made the 3 and the 4 in parentheses, it's still not going to change anything. So 2 plus parentheses 3 plus 4, well, 3 plus 4 gives us 7, and 7 plus 2 would then give us 9. And the same thing can be said for multiplication. If we did parentheses 2 times 3 times 4, and 2 times parentheses 3 times 4. Well, inside parentheses first, 2 times 3 is 6, and 6 times 4 gives us 24. And then 3 times 4 is in parentheses, 3 times 4 is 12, 12 times 2 would be 24 as well. So the way that we group numbers in parentheses, that does not matter if we are adding or multiplying. Because that's commutative and associative property. 3 other properties that we're going to see is the additive identity, the multiplicative identity, and the multiplicative property of 0. So pause the video, go ahead and get these 3 properties down. Okay, so the additive identity, obviously we're going to be doing addition, and that's when you add 0 to any number, the answer stays the same. That number does not change. So if we add 0 to anything, we're going to end up with the number that we had in our problem. So for example, if we did 2 plus 0 or 0 plus 2, we're still going to get 2 as our answer. Okay, so adding 0 is not going to change that number. Similarly, the multiplicative identity, so both of these are identity properties, and basically what they're saying is when you perform the operation, the number that you do the operation to, nothing happens, nothing changes. So if for multiplying, it's not times 0, it would be times 1. So 2 times 1 stays 2, and 1 times 2 would also stay at 2. Okay, so multiplying by this number, nothing's going to happen to that 2. It's still going to stay the same. And then the multiplicative property of 0 says that if you multiply any number by 0, your answer is also going to be a 0. So 0 times 2 or 2 times 0, you get 0. So 0 times anything, you get 0 as your answer. So those are the other 3 properties. Notice that with all of these properties, it's only with addition and multiplication. So we'll see here a little bit later if we can use any for subtraction or division. Okay, but these are our 5 properties. So the way that our examples are going to work in this section are they're going to show us a couple of problems, and then we've got to state, okay, what's the property shown in that statement. So for this first one, notice what's happening. Okay, in this case, the 5 times n is in parentheses. This time, the 2 times 5 is in parentheses. The order doesn't change. Okay, the order is not changing. It's still 2 is first, 5 is second, n is third. What's changing is what are in parentheses. And so what's in parentheses would be the associative property. The associative property, and then one other thing that I want you to do is specify which operation it's for. In this case, just put a times sign in parentheses. One thing that I do want to make sure that we don't do, my first year of teaching, I learned this the hard way, and that is do not shorten the word associative. So don't try to abbreviate it, don't try to shorten it, because my first year of teaching, we were writing the answers up on the board really big, and a student shortened the word associative and didn't realize what they had done, and that was up on my board. So make sure that you actually write out the word associative, just so we keep it clean, I guess we could say. So associative property, because what's in parentheses is changing. Okay, for our second example here, we've got 3x plus 0, and then our answer would be 3x still. So this is saying if you add 0 to something, that number is not going to change. Well, look back at your chart if you need to. When you add 0 and nothing changes, that is called the additive identity. So the additive identity, we add 0 to a number, nothing happens. Okay, let's look at a couple more examples. So this next one, you're adding, and notice what's happening. Okay, if you look carefully at it, we've got 42xy, 42yx. So we are changing the order of x and y, so that would be the commutative property. So the commutative property of addition. So we'll put an addition sign there in parentheses. All right, and then our next one, so notice, look carefully at this one. Okay, there are parentheses, and a lot of times students see parentheses, they automatically say, well, that's the associative property because what's in parentheses is changing. But notice what's happening. Okay, on the left-hand side, what's in parentheses? 3 times m. On the right-hand side, what's in parentheses? 3 times m. So what's in parentheses is not changing. 3 and m is still in parentheses. Notice what is changing. You've got 2 in front of 3 times m, and here you've got 2 behind it. So the order is what's changing. If the order is changing, that is not the associative property, that's the commutative property. of multiplication. So just because you see parentheses doesn't always mean it's the associative property. In this case, it's the commutative property because the order is what's changing, not what's in parentheses. Okay, so you can always look back at your chart if you need to see what property is shown. But I want you all to do these two on your own, so pause the video real quick, answer these two. All right, so this first one, notice that you're taking this and multiplying it by 0, and when you multiply it by 0, your answer is 0. Well, looking back at our chart, if you multiply something by 0 and you get 0, that is called the multiplicative property of 0. Multiplicative property of 0 kind of tells you what it is there in the name. Okay, then we've got you're multiplying 3 times m by 1, and you are getting 3 times m. Nothing is happening, so that is called the multiplicative identity. So that is your answer for those two. Okay? So moving on from the properties, another type of example that we're going to see is giving counterexamples. So think back to the start of this, whenever we talked about in our vocab what a counterexample is. A counterexample is one example that shows that this statement is false. So we're going to basically assume that it's false because this says division of whole numbers is commutative. In other words, does the commutative property work for division? Commutative property says we can switch the order around and nothing's going to change. Well, that wasn't in our chart, so it's probably going to be false. And just pick two numbers. So let's pick 4 and 2. 4 divided by 2 equals 2. Commutative property says switch the order around. So instead of 4 divided by 2, we're going to do 2 divided by 4. Well, does 2 divided by 4 get us 2? It does not. It is actually going to be 1/2. And so because 2 is not equal to 1/2, this statement would be false. Okay, so that's using one example to prove that this statement here is false. All right, so let's look at our next one. Okay, the statement there that we've got to think about is subtraction of whole numbers is associative. So when we subtract, does the associative property work? Remember what the associative property says. The associative property says that the way the numbers are grouped, so what numbers are in parentheses, it does not matter. You're still going to get the same answer. So let's take 3 numbers. Let's take 6, 3, and 2. Okay, 6, 3, and 2. So let's put 6 minus 3 in parentheses minus 2. And then let's put 3 minus 2 in parentheses. All right, so parentheses first. 6 minus 3 is 3, and 3 minus 2 gives us 1. 3 minus 2 is 1, and 6 minus 1 is 5. So 1 is not equal to 5. As long as we can show one counterexample, that's good enough. 1 does not equal 5, so this statement would be false. Okay, so counterexample is one example showing that the statement itself is false. So let's look at one more dealing with a counterexample. Okay, so this one you've got to maybe break down and make sure we understand what it's saying. So the difference of 2 different whole numbers. So difference, remember, means to subtract. So when you subtract 2 different numbers, your answer is always less than both of the numbers. When you subtract 2 different numbers, your answer is always less than both of the numbers. Pause the video if you want. Think about this for a few seconds and see if that's going to be true or false. So it's probably going to be false. Okay, you got to think, when you subtract, your answer is not going to always be less than both numbers you're subtracting. For example, let's take 10 minus 1. This is saying that when we subtract, our answer has to be less than 10, and it has to be less than 1. Well, 10 minus 1 is 9, and 9 is not less than 1. So this is false. So because when we subtract two numbers, the answer is not less than both of those numbers, this statement would be false. Okay, so that's dealing with counterexamples. Remember, counterexamples, it's one example that shows that that statement is false. And so this example shows that this statement is false, and so we are good, good with that. Okay, so properties of operations, you're going to be looking at different problems and telling me which property is present in that problem, and then you might also have to give a couple of counterexamples as well that prove that a statement is false. So you might want to have your chart handy to look at the properties and pick out which one is correct. Okay, so you all can work on the practice problems, and hopefully you're able to get these done without too big of an issue.